Alright, so in this equation, I have 3 to the power of x to the power of 3 over 9 to the power of x is equal to 81. So, to solve this, I'm going to first write 9 as 3 squared. So I get 3 to the power of x to the power of 3 over 3 squared to the power of x is equal to 81. And if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 3 to the power of x to the power of 3 over 3 to the power of 2 times x, so 3 to the power of 2x, is equal to 81. I'm going to rewrite as 3 to the power of 4. So now notice how I have everything in the base of 3. So this is going to make it much easier to solve. Now, if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So 3 to the power of x to the power of 3 over 3 to the power of 2x is going to equal 3 to the power of x to the power of 3 minus 2x, which is equal to 3 to the power of 4. And now, if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So x to the power of 3 minus 2x is equal to 4. And now if I subtract 4 on both sides, I get x to the power of 3 minus 2x minus 4 is equal to 0. Now we have an equation here, and this isn't a regular quadratic equation because we have a power of 3 here, and we have a missing power of 2. We don't have the power of 2. So to actually solve an equation like this, what we have to do is we have to test out values, and then once we get a value that works out, we have to use that one value to find all the remaining values that are solutions to the equation. So let's first start out with 1. If x is equal to 1, then I get 1 to the power of 3 minus 2 times 1 minus 4, which does not equal 0. Now if x equals 2, I get 2 to the power of 3 minus 2 times 2 minus 4. 2 to the power of 3 is 8. 8 minus 2 times 2 is 4, and 4 minus 4 is 0. So this does equal 0. So 2 is a solution. To be more precise, x equals 2 is a solution, meaning x minus 2 is equal to 0. So now what we're going to do is we're going to divide x minus 2 with x to the power of 3 minus 2x minus 4. So I get x to the power of 3 minus 2x minus 4 over x minus 2. And to solve this, we're going to have to use synthetic division, and if you guys don't know what that is, I would recommend watching a YouTube video on it. So our coefficients of our numerator is 1, -2, and -4, and then we have a 2 over here. I'm going to bring down 1. 2 times 1 is 2. -2 plus 2 is 0. 2 times 0 sorry, I actually did something wrong. We should have a 0 in here because, remember, we have a power of 2. So because there's no power of 2 here, we just put a 0. Now, if we bring down 1, we get 2 times 1, which is 2. 0 plus 2 is 2. 2 times 2 is 4. -2 plus 4 is 2. And 2 times 2 is 4. -4 plus 4 is 0. So we have a remainder of 0, and we get x squared. Our coefficient is 1 plus 2x, coefficient is 2, plus 2 at the end. So I get x squared plus 2x plus 2 is equal to this. And this also means that x minus 2 times x squared plus 2x plus 2 is equal to 0. So for this equation, I get x minus 2 is equal to 0, and x squared plus 2x plus 2 is equal to 0. For x minus 2 equals 0, x is obviously equal to 2, and we already got this solution before, so this is no surprise. Now for x squared plus 2x plus 2 equals 0, to solve this, we have to use the quadratic formula, which is -b plus or minus the square root of b squared minus 4ac all over 2a. So I get x is equal to negative 2 plus or minus the square root of 2 squared, which is 4, minus 4 times a, which is 1, times c, which is 2, all over 2a, so 2 times 1. And now this is equal to negative 2 plus or minus the square root of 4 minus a, which is negative 4, over 2, which is equal to negative 2 plus or minus the square root of 4 times negative 1 over 2, which is equal to negative 2 plus or minus 2i. Square root of negative 1 is the same thing as I, over 2, which is the same thing as negative 1 plus or minus I. So my three solutions to the equation are x equals 2, x is equal to negative 1 plus I, and x is equal to negative 1 minus I. Alright, so in this problem, I have a to the power of 3 plus a squared is equal to 392. So I obviously want to find the value of a here. So for my solution, I'm going to first start by rewriting my equation here. So I get a to the power of 3 plus a squared is equal to 392. And now I'm going to subtract 392 on both sides. So then these two cancel out, and this turns into a to the power of 3 plus a squared minus 392 is equal to 0. Now from here, I can rewrite negative 392 as negative 343 minus 49. And the reason I did this was because 343, this is something cubed, and 49 is something squared. And notice how we have something cubed, something squared. So I'm going to change the order of this. Actually, first, I should rewrite 343 as 7 cubed and 49 as 7 squared. So we have a cubed plus a squared minus 7 cubed minus 7 squared. Sorry, this is 0. And now I'm going to change the order to this to group the cubes and then group the squares. So I have a to the power of 3 minus 7 to the power of 3 plus a squared minus 7 squared is equal to 0. Now, here are two properties that we're going to use for this. So to start, if I have something in the form a to the power of 3, actually I should do x to the power of 3 minus y to the power of 3, this is equal to x minus y times x squared plus y squared plus xy. And now if I have something in the form x squared minus y squared, this is equal to x plus y times x minus y. So in this case, x is equal to a and y is equal to 7. We're going to first start by rewriting a to the power of 3 minus 7 to the power of 3 in this form. So this is going to be equal to a minus 7 times a squared plus 7 squared plus 7 times a, which is just 7a. And now I have this plus x squared minus y squared. This is x plus y times x minus y. So it's going to equal a plus 7 times a minus 7. And this is all equal to 0. Now notice how both of these terms have a common factor of a minus 7. So if I factor out a minus 7, I get a minus 7 times a squared plus 7 squared plus 7a plus a plus 7 is equal to 0. And this simplifies to a minus 7 times a squared plus 8a plus 49 plus 7, and 49 plus 7 is 56. So this is equal to 0. Now from here, I get two equations. I get a minus 7 is equal to 0, and I get a squared plus AA plus 56 is equal to 0. So for a minus 7 equals 0, I can add 7 on both sides. So these two cancel out, and I get a equals 7. And for a squared plus AA plus 56 is equal to 0, I can use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is 8, and c is 56. So I get a is equal to negative 8 plus or minus the square root of b squared, so a squared minus 4 times 1 times 56 all over 2a. And this is equal to negative 8 plus or minus the square root of 8 squared, which is 64, minus 4 times 56, which is 224, all over 2. And this turns to negative 8 plus or minus the square root of negative 180. And notice how we have the square root of a negative number, so this will not work. So our only solution is a equals 7. So now to check, the original equation was a to the power of 3 plus a squared is equal to 392. So we have a equals 7, so I get 7 to the power of 3 plus 7 squared is equal to 392. Now, 7 to the power of 3 is 343, and 7 squared is equal to 49. So I have 343 plus 49 is equal to 392, meaning 392 is equal to 392.